So yesterday we talked about just the area between two curves where f was greater than g for all the values of x on the interval. If, however, it oscillates, as we see in this example, f is in blue here, it is greater than g up to this point, and then g is actually greater than f, and then f goes back to being greater than g. We have to split that integral into separate parts. So what we would actually have to do here to find the total area between these two curves, f minus g, you'd have to add those three separate areas up. So what that actually means for us is we'd actually have to split this integral into three parts. In this example, we'd go from a to whatever this point would be. Let's say that's x1 of our upper function f of x minus g of x dx. And then we'd have to add this integral here from x1 to x2 of, now g of x is greater than f of x, so you'd have to do g of x minus f of x dx, and then since f goes back to being greater than g, you'd add the integral from x2 up to b of f of x minus g of x again. So let me show you what that looks like with this example here. Find the area of the region bounded by the curves y equals sine of x, y equals cosine of x equals 0, and x equals pi over 2. So you have two curves here, your sine and cosine wave. First, making sure that you're in radian mode before you graph this. The sine of x can be your first function, the cosine of x will be your second function. If you just have your basic graph set up like this, you're not going to be able to see it very well. Okay, so what we want to do is we want to change our window. Now, because we're going from x equals 0 up to x equals pi over 2, our x min can be 0, and our x max, I'm going to go a little past that. I'm just going to say pi. And because we are in a sinusoidal function, we want to, let's say we count by pi over 4. Now, max and min functions for the sine and cosine are -1 to 1, so again, just showing the whole picture, let's just go -2 to 2. And now we get to see a little bit better picture of what's going on. So our sine function starts at 0, goes to its max, goes back to 0 at pi. Our cosine function starts at our max, goes to 0, and then to our min by pi. Again, this is just half the cycle. But what we really want is just half of what is shown, because we're just going from 0 to pi over 2. So you see from this example here, cosine is greater than sine up to this pi over 4 value. That's when they're equal. And then it changes. So then sine is greater than cosine. So this one is going to be split into two parts here. We have the integral from 0 to pi over 4, where, again, the cosine function was greater than the sine function. So we have to have cosine of x minus sine of x dx. Plus, then it flips. Now sine is greater than cosine up to that pi over 2 value. So our other one would be the integral from pi over 4 up to pi over 2 of sine of x minus cosine of x dx. And now that we've got that figured out, taking the antiderivatives of this, again, we want to remember how to do this by hand. So antiderivative of cosine is just sine. Antiderivative of negative sine is cosine. So this actually becomes sine of x plus cosine of x evaluated from 0 to pi over 4. Over here, this one, antiderivative of positive sine of x is negative cosine of x. Antiderivative of negative cosine of x is negative sine of x. And this is evaluated from pi over 4 to pi over 2. So we just evaluate each of these separately. Again, don't assume that we're just subtracting 0 here, because we're not. So we have the sine of pi over 4 plus the cosine of pi over 4 minus the sine of 0 plus the cosine of 0. Okay, that's this one over here. And then over here you'd have negative cosine of pi over 2 minus the sine of pi over 2 minus negative cosine of pi over 4 minus the sine of pi over 4. And remember, we're adding these two integrals together. So the sine of pi over 4, if you don't remember what that is, just type it into your calculator. But I guess with the AP exam, you don't really need to worry too much about that. You probably would need to remember it, though, that that's square root of 2 over 2. But for our purposes here, you can get away with 0.707. And I already told you that sine and cosine are equal at pi over 4. So that's what we would get from this one. Sine of 0 and cosine of 0, hopefully, again, you have those memorized. Sine of 0 is 0, but cosine of 0 is 1. So that's what you would end up with for that example, that part right there. Pi over 2 would be at the top of your unit circle, if you remember that at all. Cosine of pi over 2 is 0. It's the x-coordinate at 0, or at 90 degrees, which is 0. So you have negative 0, technically, minus 1. Sine of pi over 2 is 1. So it's minus 1 there. Minus the cosine of pi over 4 minus the sine of pi over 4. Well, we already evaluated those over here. So you have negative 0.707 minus 0.707 root 2 over 2. That's what that is. So then we simplify this. 1.414 minus 1, and then plus, you would have negative 1. This is negative 1.414, but here it's a minus, so you have negative 1 plus, a giant plus sign, 0.414, so positive 0.414. So you end up getting 0.414 plus 0.414, which equals 0.828. And again, you can check this on your graphing calculator if you would like to. Yeah, and I just tried to do that. It wasn't working out so well for me. I couldn't get it to show you the final answer altogether, but each of these halves is 0.414. So just add it together, you get 0.828. So we did get this one right.